Okay, so as we just keep building along here into omitted variable bias, I want to return us to the idea of the disturbance term. In particular, I actually just want to rearrange this formula so that we're concerned with yi. So we get this idea of yi, we can add this expectation over to the other side and then swap the sides. So it's just a quick algebraic adjustment. So yi is the same thing as saying yi equals the expectation of y given xi plus some disturbance term. And so when we have this, then what we would say, and we could use an example again, so we could say Tom. So Tom earns $36K a year, and this was basically the same thing as saying Tom was expected to earn $44,000 a year given his 12 years of education, and then we were just adding negative $8,000 to get to his $36,000 a year. That is his disturbance term. So the disturbance term basically is just the part of this function if we look at each individual that takes us higher or lower on that, or off of our line of best fit, such that we actually hit the true observed value. And what I want to do then, because this is where a lot of confusion lives in econometrics, is say what the expectation of y given xi is that you'll normally see in a textbook, and juxtapose that with one quick aside that I'm going to give you that'll probably help you internalize this a little bit more. So, and why they kind of oversimplify it because they just assume you know this, I think. But, and maybe you do, I don't know. But I'm venturing to guess that most people probably searching out YouTube tutoring channels for econometrics aren't having as pleasant or as detailed of a time in their own coursework as what I'm trying to provide. So you'll see this, beta naught plus beta 1x x1i. And so that would be the expectation of y given xi, and then they just say, yeah, this is the formula for it. This is very, very sloppy. And so there's a reason why I did the model approximation video. So recall, if you have a line of best fit, you still have error terms for each individual observation, or almost every individual observation, presumably. Maybe you get lucky, you strike one. But a line of best fit typically only hits, one or two, maybe data points, but in reality, most data points have some sort of error term. The key here, though, with this idea of EI returning us for a moment to Intro to Statistics, is that it's just a representation of the difference between a particular point on a line and the actual line's prediction. And so that's EI. Now, why do econometricians get rid of this EI term, or assume it away, or they don't express it? Because EI isn't what we're concerned about. And so for them, if some error is to be expected, but as I hope you sort of gleaned, suppose we had a slope or an intercept error, those errors would cause bias in our entire model. So if it was the case that our error term was covariating with our x term, that was to say that our slope was wrong. And so we had to adjust our slope in some way, and then that would return to us this neutrality idea where the covariance between those two equaled 0, and so that told us it was neutral. Same thing with the intercept. If we ended up just too high or too low on the intercept, then it would come back as the sum of our errors would actually equal something that wasn't 0. And again, that was telling us, no, in fact, your target intercept is off. You just need to adjust it mathematically, mechanically. And so it's this idea that I'm expressing to you, and that I wanted to impart on you all, is that it's the ability for us to repair and return to, in essence, what we would say the line of best fit is, because in either of those cases, if this covaries with x, or if the sum of these is not 0, then our residual of some squares that we've seen before would be higher than it could be. So that would imply that it's no longer the line of best fit. But the most important factor here in these EI terms is, and in econometrics we just assume this is, no, we did our math right, we did our slope right, or if we didn't, we can fix it. And we can fit our slope such that it is minimized the errors, and so we don't have any inherent mathematically related or mechanically related bias in our example or in our line of best fit. And so that's where they'll start to ignore this EI term. Now, I want to do one other quick thing, and then we'll I know I'm going to split these more than likely into a lot of videos, so I apologize. I'll see about maybe splicing this stuff, but it depends on how much time I have to search out a program that I can do it. And then it's easy to transition between YouTube. But anyways, beta naught, beta 1, xi, ei. So if we have ei, this is now what I'm saying, okay, we could think about as y, the expectation of y given xi. If we have, I have one other equation I want to throw at you, and that's this idea that ui actually, so when econometricians ignore this term, it actually gets subsumed more often than not just under the ui term. But again, they don't care about it because the model is still considered neutral, and so they say, okay, that term's fine. The issue of econometrics is this other term. We could call that term gamma I. And so I like splitting these into two terms so you can distinct them. And gamma I is different than EI. EI we can fix. We can have a line of best fit. We get rid of all potential bias out of our problem. But gamma I, what this is saying is we have some sort of omitted variable that is actually affecting our x variable, and it's affecting our dependent variable, in this case our y variable. So it's both it would have to both covary with the x term, and then also it has a causal relationship with our dependent variable in addition. And so I'm going to leave this a little short here. So we're going to just springboard here. The only other thing that I want to do, because we're going to talk about gamma more, but you will normally see then an expression like this in econometrics, where y equals the expectation of y given xi. So that would say, oh, that's only beta naught plus beta 1 x1i. And then they would subsume this ei term into ui. So they would just say plus ui, but you could think of this as saying, no, in reality, yi would be composed of ei, and then potentially, if we have some sort of bias or problem, which we'll see next time, gamma I. And so this is going to be the topic of my next video. Until then, I will see you guys next time.